All right, so is nuclear energy the answer? Big question, right?
Yeah, a big one. And a timely one.
For sure. I mean, you've sent us a ton of stuff on these articles, reports, even that DiCaprio quote about the planet's alarm clock going off.
Right, which is unfortunately pretty spot on.
Totally. Melting ice caps, rising sea levels. It's like the whole climate change bingo card is filling up.
No doubt. And that's why nuclear is back on the table for a lot of people.
Yeah, it seems like folks are really trying to figure out if it's the lesser of all the evils.
It's definitely got its pros and cons, like any energy source. But before we even get into that debate, I think it's worth a quick level set.
Totally. How does this whole atom splitting thing even work?
So it starts with this thing called fission. Basically, you take a uranium atom,
Which is like radioactive and stuff?
right? It's already naturally decaying, releasing energy. And what we do with nuclear power is we harness that release, but in this really controlled way inside a reactor.
Okay, so you split the atom, get a bunch of energy. Then what? How does that power my house?
That energy comes off as heat, and we use it to create steam. Actually, it's pretty similar to a coal plant, just with, a way more energy-dense fuel source.
Okay, so instead of burning coal, we're splitting atoms. Got it. And that's where the whole clean energy thing comes in, right?
Exactly. No carbon emissions to worry about.
Which is kind of the whole point, right? I mean, back to the melting ice caps and all that.
Right. It's about reducing our impact on the climate.
Yeah.
And it's not just that it's clean, it's also crazy efficient.
Yeah.
You take a single uranium fuel pellet.
Okay.
That tiny thing has the same energy potential as a ton of coal.
Wow. Okay, that's a lot. So we're talking major energy, no carbon. Sounds pretty good so far. But I gotta ask, what about safety? Chernobyl, right? That's
Yeah.
what always comes to mind for me.
Chernobyl is like the elephant in the room, or I guess the radioactive cloud over the entire nuclear conversation.
And understandably so.
Oh, absolutely. It was horrific. But here's the thing. Chernobyl was a product of its time,
Meaning,
meaning the technology has advanced a lot since then, like a lot. Modern plants, they're designed with all these backup systems, safety protocols. I mean, these things are built to withstand like almost anything.
so they've basically engineered out the risk of another Chernobyl.
Well, I mean, nothing is ever 100% foolproof,
Right.
but the likelihood of something like that happening today, it's astronomically low.
Oh.
And it's important to remember, even with Chernobyl, nuclear still has one of the lowest fatality rates per unit of energy produced compared to other energy sources.
Really? Even lower than like solar and wind.
Statistically, yes.
Yeah.
There are a lot of factors that go into it, but yeah,
Huh. See, I wouldn't have guessed that.
it's not something people always think about.
So it seems like we're always weighing these potential risks, even if they're small, against this big need for cleaner energy.
Exactly. And it's not just about potential accidents either. There are these long-term considerations. Like, what do you do with the waste?
Right. You can't just like throw it away.
No, not at all. We're talking about stuff that's radioactive for a very, very long time.
And that's where that whole long-term quarantine idea comes in, right? What does that even look like? Giant underground bunkers or something.
Well, it's a bit less sci-fi than you might think,
Okay.
but the challenge is very real. That spent fuel, it's dangerous for thousands of years.
Thousands of years. How do you even wrap your head around that?
Right. So the question is, how do you contain something safely for that long? And where?
Okay, so where do you put it?
Well, that's what we're trying to figure out.
Yeah, and like, how do we even figure that out? Where do you even start?
Well, for now, that spent fuel mostly gets stored in these things called dry casks.
Dry casks, okay?
Yeah, they're these super heavy-duty containers, steel and concrete, designed to keep everything sealed up tight. But
Hmm.
it's not a permanent solution. More like buying time while we figure out something better.
Okay, so while we're buying time, let's talk about something else. You mentioned the water usage. What's the deal there?
Yeah, so nuclear plants, they need a lot of water. A lot. Mostly to keep everything cool, prevent overheating.
Which is why they're always built near a river or the ocean, right?
Exactly. They need a constant supply of that cool water.
Which wouldn't be great in a drought or something.
And you're catching on. Yeah, as climate change gets worse, water scarcity is going to be a bigger and bigger issue. And if your power plant needs a ton of water to function,
Not ideal.
not ideal at all. And it's kind of ironic, right? Like, we're trying to solve this environmental problem, but we might be creating another one down the line.
Yeah, it's like trying to put out a fire by throwing more fire on it.
Pretty much.
Yeah,
And then
yeah.
you add in the cost factor.
Right, because building one of these plants is not cheap.
Understatement. We're talking billions, with a B. Billions of dollars, years of construction, plus the upkeep, the maintenance.
So it's this massive investment, and then there's always that risk, however small, of something going wrong.
Exactly. You've got that potential for disaster, which factors into the cost. Safety is paramount. Regulations, security, all of that adds up
It makes you think about short-term versus long-term costs, right?
all the time.
Yeah,
Because, yeah, fossil fuels, they're cheaper up front, but the cost to the planet down the road, that's a whole other conversation.
for sure. So we've got water, we've got cost, and we still haven't figured out this whole waste storage thing. What are our options?
So right now, the option that seems the most promising, at least for the long term, is deep geological repositories.
Okay, so like burying it.
Basically, yeah. But it's not just digging a hole. You have to find these stable geological formations deep underground, far away from anything that could compromise it. Earthquakes, groundwater, you name it.
And I'm guessing that's not easy to find. Or cheap to build.
Right. On both counts,
Yeah.
it's a huge challenge, logistically, politically, because you also have to consider the people who live near these potential sites. Not everyone's going to be thrilled about having nuclear waste as their neighbor.
It's interesting how often we keep coming back to public perception with this, right? It's like, we can talk about safety protocols and how unlikely another Chernobyl is.
Totally.
But there's still that fear factor, that image of like glowing green goo.
It's understandable, though, right? I mean, nuclear power just sounds scary to a lot of people. The decades of, like, Cold War movies and stuff haven't helped.
For sure. So how do you change that? How do you get people to look beyond the fear and actually see the potential benefits?
It's a tough one. I mean, I think transparency is a good place to start. Being upfront about the risks, but also shouting from the rooftops about how much safer the technology has become, and education, of course.
Yeah, helping people understand what it is, how it works, why it matters.
Exactly. Because if people don't understand why we're even considering nuclear, all the safety features in the world won't really matter.
Totally. And speaking of understanding how it works, what about those new reactor designs, the ones Bill Gates is investing in? I read that they're supposed to be way safer and more efficient.
Yeah, so that's the next generation of nuclear technology. They call them Generation IV reactors.
All right.
And they do have some really cool features. They're more efficient, they produce less waste. Some of them can even use the existing waste as fuel.
Wow, like actually recycle it.
Yeah, pretty much. So there's some really innovative stuff happening. But,
There's always a but,
right, we're still in the early stages with a lot of this.
meaning it's going to be expensive to develop.
Very. And it's going to take time. Plus, we still need to figure out if some of this tech can actually live up to the hype.
So even with these like cutting edge solutions on the horizon, it still comes back to weighing all the angles, right?
Right. Nuclear has some big potential advantages, but it's not a silver bullet.
No.
And any conversation about it has to acknowledge the very real risks, too.
Exactly. And that's what makes it such a fascinating conversation to have. There's no easy answer, just a lot to learn and consider. It's kind of mind-blowing when you think about it. This one question, is nuclear the answer?
Yeah.
And it just spirals out in every direction.
It really does. Because it's not just about the science, right?
Right. Exactly. It's about economics. It's about politics. It's even about, like, what we believe in as a society.
Absolutely.
Yeah.
What level of risk are we willing to live with? What's important enough to prioritize, even if it means making sacrifices somewhere else? These are big questions.
Big questions, and not the kind you can just Google for the answer.
Nope. No easy answers here. And that can be uncomfortable for people, I think, because we're so used to wanting, like, clear-cut solutions.
Totally. But with energy, and especially something like nuclear, it's always going to be more complicated than that.
Way more complicated.
Yeah.
Because we're talking about things that affect everyone, everywhere.
Exactly. So for our listener who's been with us through this whole deep dive, all the pros, all the cons, what's the one thing you hope they take away from this conversation?
Honestly. Don't let it overwhelm you.
That's good advice for a lot of things in life, actually.
Right. But especially with something as complex as energy, it's easy to get bogged down in all the details, all the what-ifs, and just feel stuck.
Oh, yeah. Analysis paralysis, for sure.
Exactly. So I guess what I'm saying is, yeah, learn about this stuff, stay informed, but then take that knowledge and actually do something with it.
Love that. Because even small actions, when they're informed actions,
They can add up to big change. And when it comes to the future of energy, and really the future of the planet, we need all the informed action we can get.
couldn't agree more. So keep asking those tough questions, keep learning, and most importantly, keep the conversation going. Because whether or not nuclear is the answer.
It's definitely part of the conversation.
Exactly. And understanding that conversation, engaging with it, that's how we're going to find our way to a cleaner, more sustainable future. Thanks for joining us for this deep dive. Until next time.